Key concept 9, target C. YouTube channel is Math Videos by Mr. A. Make sure to subscribe to the channel. Also turn on notifications. That way you're reminded every time a new video comes out. Enjoy. In target 9b, we looked at what the graph of an exponential function looks like. We saw exponential growth, we saw exponential decay. We focused on the basic exponential function rule, which was f of x equals a times b raised to the x. We did have a plus or minus c as the exponent and then a plus or minus k. This time around, though, we're looking at the most basic form. So, again, f of x equals a times b raised to the x, where a is your initial amount and b is the rate. Now, there are a couple other formulas that are a little bit more specific. They break it down for situations when we use exponential growth and exponential decay. So we're going to be looking at some word problems. The way we know we're going to have to use exponential growth is if they use words like enlarge, increase, interest, or growth. I think we're familiar with most of those words except maybe interest. Interest is, for example, let's say a friend loans you $20 because you don't have that money with you right now. You'll pay the $20 back, but he's going to charge you interest. So you might say, hey, I want 2% interest, and so when you pay him back, instead of giving him $20, you're going to give him like 22. And if we're going to use exponential decay, we're going to look for the following words: reduce, decrease, depreciates, and decay. Again, most of those words you should be familiar with either in math or in science. Depreciates just means that the value of something goes down with time. So for example, if you buy a brand new car for $20,000, the minute you leave the parking lot, the dealership with it, it's no longer worth $20,000. The price has depreciated, so it's gone down in value. Now, the one for exponential growth is f of x equals a times the quantity 1 plus r raised to the x. So you'll notice that it's a lot like the previous one, except b got replaced with the quantity 1 plus r. Okay, so we already know from previous that a is your initial amount. Okay, it's whatever you begin with. R is going to be the rate of growth in this case. Rate of growth. And we're going to want that as a decimal. So for example, let's say they give me 50%. I'm not going to use the value 50. I'm going to want that as a percentage. So we're going to take that 50 and we're going to divide it by the greatest percentage possible, which is 100. So we will have to divide by 100. Okay, and that'll make a little bit more sense when we see a specific example. And then x will have something to do with time. Okay, whether it's minutes, days, hours, it'll depend on each problem we see. Okay, exponential decay, again, the formula to that is very similar. It's f of x equals a times the quantity 1 minus r raised to the x. So again, it's the same as the previous one right here. This one right here, it's just that b got replaced with 1 minus r, which makes sense. If you want something to grow bigger, you should add. If you want something to get smaller, we're going to subtract. So a will still represent the initial amount, okay, whatever we start with. R is now going to be the rate of decay. So how fast is it getting smaller? Again, as a decimal. So if they tell me that something is decreasing by 13%, I don't necessarily want the percentage. I want to know how much out of 100, so I'm going to divide by 100. And then x, again, has something to do with time, according to whatever the problem tells us. And these two formulas, a hint that we're going to want either exponential growth or exponential decay, will be the fact that if they tell me that something is growing or decaying by a certain percentage. Example 1. Write an exponential function that models each of the following situations. All right, so A says a speedboat purchased for $18,000 decreases in value 15% each year. So we're looking for a word that tells us either if we're going to want growth or decay. In this case, the word the word decreases tells me that we're going to be looking at exponential decay. So I'll start with that. Okay, exponential decay. So as a reminder, the formula is f of x equals a times the quantity 1 minus r, because we want the values to get smaller, raised to the x, where a represents your initial amount. The speedboat purchase was for $18,000. R will be the rate of decay, 15%. But remember, we don't want it as a percentage. We want to know the decimal equivalent out of 100, so we divide it by 100, and it's going to give me 0.15. Now, x has something to do with time. They do mention year, but that's also how often it decreases every year. We would only put something in for x if it said something like, I want to know the price of the speedboat or the value of it 4 years later. Okay, but since they don't tell us anything like that, we're just going to leave it as x. So then we go ahead and plug everything in. So we have f of x equals a, which we said was 18,000, parentheses 1 minus r, which we found out to be 0.15, raise it to the x. Okay, that would be an acceptable final answer. Now, if you wanted to simplify it a little bit further, technically, if you think of order of operations, please excuse my dear Aunt Sally, parentheses comes first, so we can simplify whatever comes inside the parentheses. So we'll have f of x equals 18,000, and then if we simplify what's inside the parentheses, 1 minus 0.15 will give us positive 0.85 raised to the x. Now, if you're thinking, what if I simplify it further and do 18,000 times 0.85? We can't do that because order of operations says parentheses, which we did, and then exponents. So we would have to take 0.85 raised to the x, but we don't know what x is yet, so we can't do that. And because we can't do that, we can't then try to multiply, not yet. So either one of these would be acceptable final answers for that problem. Now B says, the current balance of a savings account is $5,000 and it pays 3% interest each year. Again, looking for words that tell us whether it's growth or decay. In this case, the word interest tells me that it's increasing, so we're going to want exponential growth this time. Okay, so we'll start by writing that down. And then the formula for growth is very similar. F of x equals a times parentheses 1 plus r this time, because we want it to get bigger, we want it to grow. And then raise it to the x. Where a represents the initial amount. How much money we have in the account to begin with is 5,000. And then r is your rate of growth. It's growing 3%. Divide that by 100, it's going to give us 0.03. And again, it tells us that that's how much interest is paid each year, but it doesn't ask us how much money is in the account 4 years later or 8 years later. So we're going to leave x as x. Plug in everything that we're told. We have f of x equals a initial amount, 5,000, parentheses 1 plus 0.03 raised to the x. So this would be an acceptable final answer for part B. Again, if you want to simplify inside the parentheses, you could. So it could be f of x equals 5,000. In parentheses, 1 plus 0.03 would give us 1.03. Raise it to the x. And that would also be an acceptable answer for part B. Example 2a. A teacher drinks a coffee that contains 500 milligrams of caffeine. The amount of caffeine in his system decreases by about 24% each hour. How much caffeine will be left in his system after 4 hours? Okay, so we know we're either dealing with exponential growth or exponential decay. So we're looking for a word that'll tell us which one to use. The word here will be decreases, which tells us we're going to want to use exponential decay. So we'll start there. And we'll write down the formula, which is f of x equals a times the quantity 1 minus r raised to the x. Okay, so in the first line, they want us to write down the formula. Okay, so they want the formula that will work for any amount of hours. So let's say I want to know how much caffeine is left after 8 hours, 10 hours, 12 hours. So we want a formula that will work for any time value. So right now, all we need to plug in is a and r. A is your initial amount. So we go back to the problem. It says that he started with 500 milligrams of coffee. So we'll put 500 here. R is the rate of decay, which we're told is 24%. So we're going to take the percentage, divide it by 100, and that'll give us 0.24. Now we can go ahead and plug in the formula. So we'll have f of x equals a, which we said was 500, parentheses 1 minus 0.24 raised to the x. Again, we're not plugging anything in for x at the moment because we want a formula that will work for any time value. Now we take it one step further, and we're told we want to know how much caffeine is left in his system after 4 hours. So now we can let x, remember x has something to do with time, x can be 4. So we'll take the formula, this one right here, and wherever we see x, we're going to plug in 4. So we have f of 4 equals 500, parentheses, 1 minus 0.24 raised to the 4th. Okay. Now you can't do this all at one time. I'm just going to take it step by step just as good practice. So remember on the left, the f just tells me that what I have is a function. Okay. So I'm not going to do anything to the left. I could just bring it down as we have a function. The input, what goes in, the x value is 4. On the right, we're going to do parentheses first. So 500 parentheses. We have 1 minus 0.24. We're just going to go ahead and give us 0.76. Still raised to the 4th. Okay, again, another line, f of 4 equals, we still haven't done the exponent, so we're going to do 0.76. Raise that to the 4th power. So we're going to have 500 parentheses, and that's going to give us 0.3362176. Okay. And then we're going to go ahead and multiply those two together. And that's going to give us f of 4 equals 166.81088. Okay, so notice we ended up with some decimals slightly bigger than we would have wanted. That's okay because I think we're going to round right now. I didn't put that in the directions, but I think it'll be good practice to round. Let's say we're going to round to 2 decimal places. Okay, so if we're looking at 2 decimal places, also known as the hundredths place with the th at the end. We start with this number right here because it's in the hundredths place. We look to the right. If that number is between 0 and 4, then that 1 will stay the same. Had that number to the right, that 0, had actually been a number 5 or greater, 5 to 9, then we would have added 1 to the 1, and that would have made it a 2. So in this case, we're going to say the caffeine remaining. We're going to go with the squiggly equal sign, remember, which means approximately, which means it's really close to the exact answer, but because we rounded, it's no longer the exact answer. 166 points, that's going to remain as 81. And then what we were talking about is how much caffeine remains, so that's going to be milligrams because that's how caffeine was measured. Okay, so here is my formula, and here is how much caffeine remains after 4 hours. Example 3. The starting salary for teachers is $87,000 per year. The school automatically gives teachers a raise of 2.5% annually. Write the formula that models the situation and determine a teacher's salary in 7 years. So this is very similar to the example we just did. We're looking for something that'll tell me growth or decay. A raise tells us that they're going to be making more money. So we're looking at exponential growth. So let's go ahead and start with that. Okay, exponential growth. And we'll write down the formula for reference. F of x equals the initial amount A times the quantity 1 plus R this time because we want it to grow and raise it to the x. So we want to start with the formula first. A represents your initial amount. How much was the starting salary? 87,000. R is the rate of increase, in this case the raise, which was 2.5%. That's still a percentage, so just because it has a decimal, it's not quite decimal format. We still need to take that and divide it by 100, and that's going to give us 0.025. Okay, now we can go ahead with the formula. F of x equals A, which was 87,000, parentheses 1 plus R, which was 0.025, and then raise that to the x. Okay. Again, we're not plugging anything in for x just yet. X does have something to do with time, and they do mention time, but right now we want a formula that will work for any time value. So now we're going to take it one step further. We want to know the teacher's salary in 7 years. So now we're going to go ahead and let x equal 7. And wherever we see x in that formula, we're going to plug in 7. So we have f of 7 equals 87,000, parentheses 1 plus 0.025, raise that to the 7th. Keep in mind, the f, again, just tells us we have a function, so we're not doing anything to the left. F of 7. We're going to follow order of operations. Please excuse my dear Aunt Sally, which tells us to do parentheses first. So we have 87,000. In parentheses, 1 plus 0.025 will give us 1.025 raised to the 7th. We did parentheses, now we have to do exponents. So we're going to take 1.025 and we're going to raise that to the 7th power. But again, unfortunately, it's going to give us a really long decimal. 87,000 times the quantity 1.188685,754. Now, if we wanted to avoid all those decimals, what we could have done is we could have put all this into our calculator exactly how we see it, and it would have given us the answer right away. I'm just doing it step by step here, just so it's good practice. Also, I would not want to round at this point just yet, because the sooner you start rounding, the more off your final answer will be. And we don't want it to be that far off yet. So then we're going to take that, 1.188685754, and we're going to multiply that by 87,000. Okay, so we're going to have, again, we have a function, we plugged in 7, and what we end up getting is 103,415.6606. Okay, again, it didn't tell us, but we're going to round to 2 decimal places. So we'll start here with the 6, go to the right, because the number to the right is between 0 and 4. That 6 will stay the same, but we did round, so we'll say approximately 103,415.66. And because we're talking about salary, we'll add the $sign for this answer right here. So final answers, write a formula to represent the situation. There it is. Figure out a teacher's salary in 7 years. There it is.